So you do have an option of how you want to go about solving this out. You could choose to start taking the third root of these terms that you have right off the bat. I would not recommend that. My choice is usually always to try and reduce the fraction as far down as possible, and then I'll worry about dealing with the radical afterwards. Meaning I'm going to be asking myself, what can 24 and 36 both divide by? Well, in this case, 24 and 36 can both divide by 12. So 24 divided by 12 is 2, 36 divided by 12 is 3. Also, I notice that I have an x to the third divided by an x. Well, x to the third divided by x would be x squared. So once I've simplified, I realize that I'm looking at the third root of 2x squared over 3. Or in other words, I have the third root of 2x squared over the third root of 3. Now, as it turns out, neither of those can simplify, right? I can't do the third root of 2, I can't do the third root of x squared, and I can't do the third root of 3. Usually, we would be done then. The problem is, we know we have this rule that says we are not allowed to have a radical left over in the denominator. So we actually need to take some extra time here to take care of that third root. We need to get that third root out of our denominator. The only way we have to do that is to rationalize the denominator, meaning we are going to multiply by something to get that third root gone. Well, if you think about third roots, when we try and pull things outside of a third root, we know we need trios, or groups of 3. Right now, we have a single 3 inside that radical. So if we could bring 2 more, then we would have a trio of 3s that would come out perfectly. So since we already have 1 3, we need to multiply by 2 more 3s. Or in other words, 3 times 3 tells me we need to multiply by the third root of 9. But we have to do that on both levels, numerator and denominator. So if I do that, in the numerator, 2x squared times 9 would be 18x squared. It's a terrible 3. On the bottom, in the denominator, 3 times 9 would give us the third root of 27. And if we look here, we see that the third root of 27 does indeed come out perfectly to 3. You can do that with the factor tree, you can do it in your calculator, but it comes out nicely either way. And so all that's left is to see if we can simplify that numerator radical, meaning I look at a factor tree of 18 and see if I can find any pairs. Well, 18 breaks into 2 and 9, 9 breaks into 3 and 3. There are no trios here, so there's nothing that we can actually pull out because it's a third root, which means it just gets to stay as the third root of 18x squared. It is trios. If I said pairs earlier, that was a misspeaking. So that is our answer, and we have gotten the radical out of the denominator.